What is up, YouTube? Woo! Mr. King coming to you live. I know it's been a while. Thank you for joining me for tonight's video. Today you're going to learn how to compare and contrast nuclear fission and nuclear fusion. Okay? There will be some anime references, so please bear with me. You can just call it in your notes nuclear notes. Nuclear notes, nice alliteration. If you're curious, nuclear, all it means is just an adjective describing the nucleus. Okay? I usually like for students to do the left side, have the words, the right side have a picture, so you can remember it longer and conceptualize it better. And then if it has a star, it means it's very important. Please write it down. Okay? So fusion versus fission. Hopefully this helps you remember. Fusion means put together. So in the anime, they have a nice animation sequence where you have a monster and then another smaller monster, and then you play this card called polymerization, and then combined, you'll make a new, bigger, and better monster. So that's fusion. Fusion means put together or combine. So they'll have like the spiral spiral animation. Yep. And then they'll fuse. Fuse is put together. And then this is the one you probably haven't heard of. It's fission. Okay? So what we have here is the Blue Eyes Ultimate Dragon. So it has 3 heads. And then Fission would be splitting apart. So Yu-Gi-Oh plays this card called Defusion, the opposite of Fusion, Fission, and it splits Blue Eyes Ultimate Dragon 3 heads into 3 individual Blue Eyes Dragons. Okay? So that is Fission. Fission is split apart. Next, here's what I want you to know. Nuclear fission happens all the time. Very common. Fission basically happens when the atom is unstable. It's very common in very large atoms, which you may remember are a bit unstable because since there's so many protons and neutrons, they're so far away, the force holding them together is much weaker. Since it's so big, it's a lot harder for the nucleus to keep it all together. So, bigger atoms go through nuclear fission a lot more often. And that's why we prefer it. Okay? So nuclear fission happens all the time because it's unstable. They break to be stable again. Okay? Next, the opposite of fission is fusion. Fusion, on the other hand, is very rare. You can think of it like this. It's very easy to break something, but it's much harder to put it back together. So like, for example, it's very easy to break a pencil or to rip a piece of paper, but it's much harder to return that paper back to normal. It's just like that, but with fusion. So fusion, basically, it's very common to have one hydrogen isotope and then another hydrogen atom, and then fuse them together. They slam into each other, and then they combine. That's fusion. But you need to know, it only occurs naturally in stars. Okay? And I have a question for you. Why do you think fusion only happens in stars? Okay? It happens all the time in our sun. I want you to think, why does it only happen in stars, but not on Earth? It's very, very hard to do on Earth, but not in stars. Try and think why. Please pause the video now. I want you to consider, what do you know about the sun? Why would fusion be common in the sun, but not on Earth? Okay? Hopefully you remember the sun is super big and super hot. So, the reason why it's really easy to do in the sun, but not on Earth, is because the sun is like 1,000,000 degrees. So, since the sun's so hot, these atoms have a lot of thermal energy. So they're going to be moving very fast. So fast even that they're going to be moving so fast that when they hit each other, they'll slam into each other with enough force that when they hit, they'll combine into something new. You can think of it like if you had super speed and you accidentally ran into the Flash. If you and the Flash have enough energy, then you'll just hit each other so hard that you'll combine into a new big person. That's what it's like. You need to have enough energy and pressure or force to force the atoms to slam into each other, and when they come out, you get something new, a bigger atom. That's the idea. The reason why it works in the sun is because the sun has enough thermal energy to heat those atoms up to move fast enough to slam into each other. Okay? That's the idea of how bigger atoms, including us, were made. You just keep having enough collisions, smaller and smaller atoms slam into each other enough to get bigger atoms like carbon to make humans. Okay? Next, I want to tell you about $1 billion opportunity. I told you about one with wave power. This one, maybe even $1 trillion opportunity. You could potentially save humanity if you could figure out this problem. Okay? So, there is a nuclear fusion reactor in France. However, something is not right with our fusion reactions. Please look at my screen and figure out what is wrong. So I'm going to pause the video. Please pause the video now. Figure out what is wrong with the fusion reactions we've been doing so far. The answer is on the screen. Pause the video and try and figure it out. Hopefully you noticed that the energy input is 8.9 times 10 to the power of 10 joules. It's around 89 billion. That's how much joules of energy we put into the reaction. And then the output is 7.1 times 10 to the power of 9 joules. So that's 7.1 billion joules. Okay? So we put in 89 billion and we get out 7 billion. So the problem is we put in a lot more energy than what we get out. And that's the ultimate problem that we're trying to fix. If someone can figure out a way to make these close to equal, or better yet, even flip the numbers, you would mostly solve the climate crisis. Because never again will we have to deal with unreliable wind power or solar power, or meltdowns of nuclear power plants, or air pollution and climate change from fossil fuels. No, we would have renewable energy going all the time if we could find a way to replicate the sun and do nuclear fusion. No one's figured out yet, but that's humanity's goal. Okay? That was the last thing. Now, at the end of your notes, please write, what did you learn today? And use nuclear fusion and fission in your answer. Thank you so much, everyone, for sticking with me the whole time. Have a great night.